So next is the Spearman rank correlation, which is the alternative of the Pearson correlation coefficient, and is usually used to measure the strength and the relationship between two variables, continuous variables. So the range of the value, which is the rule, is usually between -1 to +1. Unlike the Pearson correlation, which measures linear relationship, the Spearman actually measures monotonic relationship. So in a monotonic relationship, the variable consistently increase or decrease together. They are not necessary at a constant rate and also can be curved but no reversal in direction. So how does it work? You just rank each variable separately. You calculate the Pearson correlation on the ranks, and what you have is your Spearman's rule. So this is actually the formula where this is the difference between paired ranks. Your numerical requirements are that paired observations from the same subject, data is at least ordinal, that means can be ranked, and the variables have a monotonic relationship. So there's no assumptions about distribution, shape, linearity, or almost skedasticity. It's not as strict compared to that of the Pearson rank correlation. So the magnitude, so when you have your rho to be 0, there's no monotonic relationship. Then when your rho is 0.1 to 0.3, we have a weak relationship. When your rho is 0.3 to 0.7, you have a moderate relationship. And when your rho is 0.7 to 1.0, you have a strong relationship. So the rho can either be positive or negative. So in positive, the both variables increase together. Negative, then one increases as other decreases, since the range is between -1 and 1. You use a Spearman rank correlation when your data is ordinal. It can be Likert scales or rankings, or your relationship is monotonic but not linear, and your data contains outliers. Your distribution is not normal, you can also use the Spearman rank correlation, and your sample size is also small. The advantage is robust to extreme values compared to the Pearson correlation coefficient. So the hypothesis test is that in the hypothesis there is no monotonic relationship, and the other hypothesis that in the monotonic relationship actually exists. And in that test, you calculate the test statistics, you compare to critical value or obtain p-value, and if your p is less than 0.05, it indicates significant correlation. So the Spearman versus the Pearson. So this is just the difference. You can see you can use one for continuous, the other is for continuous or ordinal data. You can use the other one for monotonic. This one is also, the other one relationship has to be monotonic, while in Pearson it has to be linear. In terms of outliers, it is robust for Spearman, while the Pearson is sensitive to outlier, and the power is also lower if linear, but it is higher if it is linear in terms of Pearson. But for Spearman, it is lower if it is linear. You can use it for any distribution, the Spearman rank correlation, but the Pearson, preferably your data has to be normally distributed. These are example scenario your educational research, whereby the class rank, we have position in the class rank, then the data is ordinal from first, second, third up to the last position. You can see this data is not continuous, but it is ordinal. So we also have the study hours per week. So the question is that, is rank associated with more study time? So why do we consider Spearman? One variable is ordinal, which is our class rank, and relationship may not be perfectly linear. I want to detect any monotonic pattern.